Our next presenter is Mike Williams. He works for Modern Automation Consulting, but I'm going to let you in on a secret. He's not a consultant, he's a user. He got dirty in Dow plants for many years, so he's been there, done that. So with that, I'm going to introduce Mike. Mike's just not very good at retirement.
Okay, first of all, thanks, Steve and colleague. We talked, to prepare for this, I actually did some extensive literature research that's out there. How many in the audience have heard about autonomous operations? Probably everybody here. Okay, just Googling that particular topic. In the last 2 years, there are over 45 scholarly articles on autonomous operations, specifically for manufacturing operations. There are many more out there on autonomous operations beyond the manufacturing shop floor, but just in the last 2 years. Some other external surveys by LNS, Gartner, some other recognized survey organizations show that fundamentally, in the process industries, specifically the process industries, roughly 75% of the companies in that space are pursuing some degree of autonomous operations moving forward. And specifically in the last 2 years, because of COVID, there's been a heightened interest in autonomous operations because of the desire for higher degree of automation, less operator involvement directly in the physical processes because of health issues, as an example. So we need reliable platforms, such as what Steve was describing, and then we need applications to run on top of those. So I wanted to avail you of the direction where we're going in this particular point in time. So there obviously is a relationship between autonomy and automation. Okay, it turns out automation is a subset of autonomy. Autonomy goes beyond automation, but autonomy does not exist without automation. So there is a relationship graphically between the level of autonomy, and we've seen it's pretty much recognized in the industry today. There are 5 levels of autonomy, ranging from 100% manual to total operatorless, totally computer operated facilities. To achieve that, and today we're going to explain what are the various elements of automation that need to be in place in order to increase your level of autonomy. So quick definitions: full autonomous. There's some key words that I want to highlight here. When you're talking about autonomy, it means without human intervention. Full autonomy, the human being is not involved. So level 5, no human involvement. As you saw by the graph there is a level of autonomy, which is a superset of automation. There's a direct proportionality between the level of automation you install in your plants and increasing the level of autonomous operations. Another important part here is you obviously have to have the sensors, some form of sensing or soft sensing to trigger the closed loop action. But the key differentiation in autonomous operation is it anticipates potential faults, not reacts to a fault, but it anticipates the faults, and it adapts. It automatically adapts to that changing situation. And you do not need, you can have mixed modes of autonomy within a facility or a business. You do not have to have a cohesive 100% all or nothing type solution. So remember the key words: anticipatory, adaptive, and no without human interaction. That is the difference between autonomous and automation. Another way to look at it is on a linear scale here. I've explained all these things, but in the context of operating a plant, of which Paul was saying I'd spent almost 40 years in industry on the shop floor, We 100% manual is your standard operating procedures, and it goes all the way to 100% computer automation. So as you're going through this path or this journey towards autonomous operations, the question is what are the prerequisites? What are the things you need to do incrementally to establish the foundation and then move forward to higher levels of autonomous operations? So I want to remind folks, this may be a repeated educational exercise for the experienced in the room, but autonomy is not something you just come from the top and drop it down on top of a facility. You have to have the infrastructure in place in order to make autonomous operations work, okay? So let's look at this journey from 100% human to no humans involved. This is a bad slide. So let me summarize it. You have the levels of autonomy, and you have different activities going on within operating the plant. So we a lot of us here started and our careers grew from higher levels of automation on the shop floor, and that certainly is a prerequisite to go from level 0 to level 5. But a truly autonomous operation includes associated work processes that interact with running the equipment. So it may be a supply chain planning activity that's fully integrated with the control system. It could be an asset performance or asset reliability applications that are autonomously operating. We call it condition-based maintenance. Fundamentally, not only predicting when something should happen, but in full autonomy, it will self-correct. So imagine, okay, so a classical example is a duty standby pump in a plant. We've got thousands of those out there. The difference between a traditional duty standby is you've got an automated piece of equipment and you've got one standing by here. Well, on our autonomy scale, that would be a level 2, maximum level 2 type application of autonomy. Autonomous operations would be fundamentally sufficient instrumentation and software to detect, predict, and react. That's the adaptive part of it. Essentially, change automatically from the online to the active to the inactive and swap over automatically. Now, some will say, well, that's technology we know how to do today. Yes, it is. But how many have actually installed it? I mean, as 8 years in the consulting industry beyond the Dow Chemical Company, very few installations out there have active redundancy on the physical equipment or autonomous operations. So we're talking going beyond traditional automation, beyond just sensing and alerting a defect, and that we're talking about identifying it without a human being involved, identifying the adaptive corrective action, and taking that action. That is autonomy. So don't be confused out there. There's a lot of confusion between autonomous and automation. I will mention here, without looking at the slide, surveys have shown that in the process industries, specifically manufacturing process industries, the vast majority, over 70%, are at level 2 today, just to give you a perspective. The industry is fundamentally at level 2. So my question to you is okay, how do I get to level 3? I mean, if I'm mainly out there at level 2, let's walk the path. Let's not try to skip some steps and jump on the top and start using some advanced techniques such as artificial intelligence or machine learning, which have value, but don't do it prematurely. You need to get the foundation set first. So how do you go from level 2 to level 3? That's my point here. How do you do that? Oops, back. Some members in the room will recognize what I'm talking about here. Improving to level 3, SBC stands for state-based control and integrated standard operating procedures. Fundamentally, you see them highlighted in the level 2, level 3 area today. State-based control. Man, I've heard that before. I think there's an ISA committee out there called ISA 106. If you don't know what that is, I mean, it's essentially model reference adaptive control for continuous processes. It can also be applied to batch, but model reference adaptive control. Come on. Okay, I'm not going to go into the mathematics like Steve did here, but fundamentally, model reference adaptive control, or the term coined state-based control, is a form of adaptive control where the model is a unit relative, unit meaning the unit operation, unit relative process states or modes of operation. Some use that term. So the process states or mode of operation for, let's say, a continuous distillation column may be, as an example, the maintenance wait position where the equipment is totally decommissioned for maintenance purposes. There may also be additional states to ramp that up into the run state being at equilibrium or steady state, and then alternative states, impaired states for keeping the process running, but not necessarily at its capacity limits, but keeping it running until the maintenance occurs. And then there are other states, shutdown and emergency shutdown. But the key point here is the objective of model reference adaptive control, emphasizing adaptive control, is that the feedback control law it changes or adapts to the process dynamics where the plant I/O properties are consistent with the reference model. Sounds like a lot of words. So the I/O in level 2, the I/O are at this level of automation, level 2. By synchronizing or coordinating the I/O associated at the unit relative application, you get a higher degree of automation and a requisite higher level of autonomy. Why? Because different states, like an abnormal situational state, can be addressed automatically. Autonomous means automatically addressing abnormal states without human intervention. So this is a foundational type of control strategy, model adaptive control, which can be employed today. All the major control system vendors out there support this. Okay, without this basic foundation, or with it, let's say it positively, with this in place, then you can start to think about adding advanced artificial intelligence or sophisticated models to enhance, I call it the second derivative of the basic control law, with this in place. All this can be done today. The little r, by the way, in this model here, that's the input to the reference model from advanced analytics or automated procedural mobility type connections. So everything happens in the context of that model reference, and it adapts based on the mode of operation. Again, bad slide. My point here is, okay, we can get to level 3 with traditional solutions that are available by most of the vendors today. But what's next? What does the 21st century need? Well, autonomy, not automation, but autonomy means look at those associated work processes with the actual running of the plant, and what can we do to autonomously, without human intervention, improve the operations with supporting or allied functions. A classical example is the supply chain, the in and out to your process, and the planning and scheduling around that. So I would propose in this very simple slide, once you have a level 3 foundation, something you could investigate to approach level 4 would be, in this case, look at autonomous supply chain. And key important parts of this, you're looking at not only one facility or one train, but you're looking at multiple facilities across an entire business unit. And we're going to hear from one of those business units right after me here. The key point here is that we're going to start using dynamic supply chain modeling with very sophisticated advanced modeling techniques for supply chain modeling. And we're going to use machine learning techniques in this inventory reconciliation to make sure that the data integrity feeding the supply chain model is clear and true. And moving from something right now which has in our type of business an inventory accuracy defect rate of about 10 to 15%. See these large storage tanks that are in these hydrocarbon and commodity chemicals plants that is feeding the ERP system has inaccuracies of up to 10 to 15%. But if we get that in place and we take the steady state models, which are used today at the ERP level, if we make those dynamic, we can do 24-hour material balances around an entire fleet of manufacturing plants to manage the supply chain and scheduling, and thus achieve better working capital reduction, both on the raw material side as well as the finished product side. This is a level 4 opportunity with the foundation, the prerequisite of the foundations we've seen. We can do the same thing with asset performance management and fleets of equipment such as pumps or heat exchangers, as an example. So autonomy is bigger than automation, but you start with the automation foundation and you build on autonomy with the associated work processes around it. Where's the value come? Okay, look at the levels, level 0 to level 5. It's an S curve. And at level 3, you see this rapid acceleration in value to go from where we are in the industry, typically at level 2, to get to level 3 or 3 plus. There's a huge amount of value out there in the areas that Paul mentioned in the preamble. As you get beyond level 3, you're looking at opportunities of enterprise level modeling, emulation, and optimization. So don't be confused about the difference between autonomy and automation. We need to get the automation foundation right first to get us to a level 3, and then we can apply some of these more advanced technologies to get to level 3 plus and beyond with the associated functions in a broader perspective than just the unit relative context. So these are, again, some of the areas that are most important. These processes are very expensive. CapEx is very high. So asset utilization improvement through higher levels of autonomy are high value opportunities. Equipment failure, condition-based maintenance, something that's not looked at very closely yet, but PLM, people may have heard of product lifecycle management. PLM is not broadly used in the process industries. It's primarily in the discrete industries such as automotive. But imagine refineries that are more agile, or imagine commodity chemical plants that are more agile to do grade changes more seamlessly, more autonomously. There's huge value to be had in that. So, and none the least, reducing the human error, as Steve was mentioning, involved in making real-time decision making. So autonomous is a big thing right now. It's the next generation. The last wave of automation was in the 80s and 90s. You heard the person from Bank of America speak that CapEx is going to go up maybe as much as 8%. That CapEx is going to be chasing autonomous operations. So you need to consider your path. So let's talk to a customer who's making some sizable reinvestments in this particular space and see where his direction is. What are his business drivers, and what does he need? What level of autonomous operations does he need that's going to create the value that he needs to justify that CapEx?